Hi, everyone. Welcome to this week's Safe Spring Saturday Seminar Series. Today, you are in for a real treat. We were alliance partners with this team at both league championships and state, so we can tell you that they know a thing or two about robots.
Today you will hear about how to be resourceful with your robot design. We are happy to introduce Lawrence Division semifinalist captain at the Florida State Championship, Team 10276 Stormtroopers from San Jose Prep School. Over to you, Stormtroopers.
Well, thank you all. I'm happy to be here. Like I said, we're the San Jose Stormtroopers, Team 10276. My name is JR. We've been around for about 5 years now, and I've been on the team since the beginning. So I'm really just happy to be here to share what makes us unique and how we can really use that to help others. So we're going to start with a little bit of team history. The last 5 years, right? We've been run out of a small 400 student 6 to 12 charter school. So already there hasn't been a lot of money to go around for after school programs. And that means we had to be resourceful. We really had to, think about what we could do when we didn't have a parts budget to even replace motors, right? Everything was coming out of coaches' pockets. And I mean, we could do fundraisers, but we didn't exactly know how to reach out to corporate sponsors yet. So that left us with a really interesting design process from the beginning where we had to start and think about every single thing that we could do to make sure that, our robot not only was unique, but could still accomplish the task at hand well. So we're gonna kind of walk you through the Stormtroopers design process, and then use that to lead into, of course, drivetrains and attachments, but really how do you put these together, because it's going to be different than the way another team would. It's that uniqueness that first thrives on. So start again with our design process. As soon as the challenge video is out, we're together in a room doing drawings like this on a board. We're just throwing out as many different ideas as we can in hopes that one or two of them are going to stick a landing. So this is actually some later stage design process from us for Velocity Vortex. So as you can see, we have it's a weird design. It's not what you usually saw, especially at the state level. But if anyone was actually if anyone on the live stream was there for Velocity Vortex, it worked. It was a design that, while unconventional, did its job. So that's kind of what we thrive on, is unconventional but does its job. So of course we start with a sketch, and sketching out every idea as possible. We come across a lot of different things, some that work, some that don't. And usually we'll stumble across, after looking at some different online resources, like Robot in 3 Days, we'll stumble across the first standard design. And that's our name for it, but that's the design that your higher level teams at states and world championships are going to be using. So for instance, this last year, your first standard design was a Mecanum drivetrain, linear slide lift, and a pass-through intake using compliant wheels, right? So you think about stuff like that, and you can build something like that, if you've got the means to, but maybe it's not going to be the best for standard design, right? So you want to question not only what can you do to score a lot of points, but what can you do that best suits your team. So that's how we end up coming up with all these different things. This next slide here, this I believe is from Relic Recovery. That's us just playing with different methods of linear motion, right? Because that's what you want to be doing. You really just kind of want to get out there and you want to play with what you have. So from there, you want to make sure that you stand out, right? You want to make sure that no matter where someone is in the room, when they see your robot, they go, "Oh, hey, that's the Stormtroopers," right? Because that's actually what helps you with finalist alliances, and that's what helps you get a name out there. So from your design process, really quick, this is from later stage relic recovery. This was us sketching out our drawer slide lift because we used drawer slides from a hardware store because they were less expensive than a linear slide kit. That's kind of what we're getting at. That was what we had the means to do. So you're going to start with your drivetrain. And I can't stress this enough. You're going to want to build your drivetrain to suit your attachments. I gave a presentation on this at kickoff this past season. So I'm going to run through really quick. There are a couple different types of drivetrains. Here, these 4 are what you usually see in the FTC. There's, of course, beginning with tank drive, which is simply, your standard wheel or standard and standard omni, oh goodness, English, combination. There we go. But so tank drive always has a central pivot, and can be 2-wheel drive, 4-wheel drive, but it's the easiest one to start with. So a lot of beginning teams will use tank drive. So then you get into your lateral motion chassis, which would be H drive and Mecanum. So H drive can use 3 motors, it can use 5, but it's stacking on these so that you can move side to side as well as forward and backwards with a pivot. So it's an extra level of motion to your tank drive. Mecanum moves in the same pattern, but through a very different way, where these Mecanum wheels spin opposite each other or towards each other in order to facilitate side-to-side movement. And then you get into your omnidirectional chassis. Now, usually you're going to see your 4-corner omni build. I know the cat ladies themselves have done this several times and done a really good job with it. Being able to place omni wheels at your 4 corners, and you can do it at 3 corners using 120 degrees of rotation, but either way, it gets you that full range of motion at the cost of speed. Usually it's at the cost of speed. Other omnidirectional chassis do include swerve drive and ball drive, but not a lot of teams are using them in FTC for the sake of a lot of motors or bulky design, right? It hasn't been fleshed out like these 4 have. So you want to build your drivetrain for your attachments. It doesn't make sense to start with a drivetrain and then try to squeeze attachments on without beginning with the end in mind, right? So that's going to involve a lot of work in the design process. What do you want to do this year? For instance, let's think about the game this year. You had some robots that could stack, you had some robots that could feed, you had some robots that could do it all, and then you had some robots that could do 1 or 2 things really well, right? So you want to start in your design process asking, what do I want my robot to do, right? What does the team think we can accomplish and accomplish well? So that's kind of where you get into some interesting attachments that you wouldn't normally see. Of course, normally you can see single pivot claws, different methods of lift, right? But a lot of that is where you can get into the personalization and the really what makes your team unique, right? By pulling from the different skill sets around you. So to backtrack just a second, we've got a lot of different resources that we don't know about. So just even out in the community, right? Our first year with a corporate sponsor was our 3rd year during Relic Recovery. And with this, it's a local sign shop by the name of Signorama. And they let us, get a hold of their misprints and just the excess sign material they didn't use, that Illuma board. And we were able to use that to fabricate parts. So our first corporate sponsor didn't give us a monetary donation. They literally let us rifle through their trash, and it made for some really unique designs. Gave us the material to fabricate parts to use side plates, right? So that we didn't have to just be using the Tetrix kit of parts that we were using, which added an extra layer of uniqueness to our robot. So when you go towards attachments, you want to be able to ask yourself, what parts do I have on hand and what parts do I have access to? But it is more than just parts. It's parts and it's knowledge, right? So those are your two main resources. You may not have access to a certain material easily, but you may have someone on your team that, say they're a good woodworker, right? Um, so then you can use that skill to really make your robot unique and fabricate parts out of wood, right? There are some laser cut wood robots out there. It's really, and that makes them unique. That makes them stand out because they're using what they have available to them. They're not trying to do something that is overextending themselves too far. So take your knowledge as a starting point and build off of it from there, the same way you're going to take your chassis and build off your attachments. So really quick, this is just a bunch of excess sign material that we were given to use for fabrication of parts, right? Lots of material that just goes into random bits of our robot. The top plate this year was made out of this material. A lot of different things that, you really want to be able to ask yourself, maybe my sponsor can't give me money, right? But what can they do? What can we do for one another? And that's where you get interesting sponsorships like this that, while unconventional, make you stand out and give you an edge over the competition. So the question really becomes, how do you build with what you have? Okay, so first you have to find what you have, right? And that's oftentimes more than what you think it is. If you're out of a school, I'm sure you have teachers that, they know more than just math, right? They may have access to a bunch of different things that can help your robot. Don't be afraid to ask. Um, being able to go out there into the community and, maybe there aren't a lot of corporations around you, but there are some small businesses that can offer um, you opportunities to get your name out there, right? Um, or that can offer you opportunities to get a hold of, part fabrication tools, right? I mean, there's a lot that you can use if you're just willing to go out and look. So we have some key examples of using what we've got. And I'm going to go through these slides pretty quickly. But it's what we've been able to do in the past and what we've built off of in the past. So this is from this year. The drivetrain on the left is our tank drive H-frame that we've been using for the last 3 years. It's solid, and we wanted to make sure it was easy to drive and easy to use. So that was our first generation, let's just build a push bot that works, right? And then over here, you've got our the beginnings of ST5, our competition bot from this last year. That's just, of course, that's bare bones, but the side plates and the phone mount for the robot on the left are made out of that Aluba board. And the bottom plate of this robot here is made out of a roadwork ahead sign that was donated to our team. So, being able to say, to see that someone's throwing something out and go, hey, I may have a use for that, right? Not being afraid to go out and say that in your community. And that's how you get your robot to stand out, because, you're not using your standard issue parts, you're using out of the box thinking to solve the first problem, right? And that's what the FTC is all about. So in this next slide, this is that same H chassis, of course, the tank drive H chassis, with some different attachments, right? Because we built a base frame that we can use to build our attachments up off of. And this is using drawer slides from Home Depot and that signboard to really just to accomplish its task of stacking a couple blocks. This is from Velocity Vortex. This was our early prototype for what sat inside of our cannon. We collected the wiffle balls from that year through a snorkeler and were able to set it up behind this mayonnaise jar that was attached to Slingshot and use that to propel it up and into the large baskets of the game field. So that, we were sitting around the house, thinking about what we can do, and we stumbled upon a mayonnaise jar that fits the wiffle ball good enough. And that was, obviously the part didn't cost much, but it worked for what it worked. It's that robo recycling principle that, we're not having to fabricate these crazy parts when there's a mayonnaise jar on hand, right? Which really makes for an interesting robot. That robot was built using a mayonnaise jar, this slingshot material, some Tetrix parts, and PVC pipe. This is like 4-inch sewage pipe, right? And that's how we got our mechanism to work. And it was weird. It was weird, but it was unique. We were really able to get ourselves out there by saying, this robot isn't just Tetrix parts. This robot is us. This robot does, it accomplishes the task, but it does so in such a unique way that you can't help but look at it. You can't help but question it. Which, so not only are you recycling, not only are you spending less money on parts, and not only are you doing better for your community, but you're also actually making a unique robot, making something that's fun and interesting. Something that, it turns heads. It gets people to notice your robot so that, even if it's not the best robot, it's on their minds. And that's what you want. This is another one of our recycled chassis. This chassis is completely made out of recycled materials, actually. The we call them pontoons, but the wheel guards on either side are made out of a stop sign that was also donated to us. And then you can see the churros from the lunar lander, and those are also bits of, I believe, the legs from the lunar lander. So we were able to look at, the parts that we got for having partial practice field, right? And build off of that. We were able to say, these are the parts that we have on hand. Let's try to build a chassis to move over things. And that's what we came up with. But, we had the resources of spare aluminum from the stop sign. We had the resources of spare churros and channels from the lunar lander, and we had the resources of an adult that understands how to teach this metal shop type stuff. So that really helped us. That was a knowledge based resource that propelled us forward, which also really helped us this past year. Right. This is ST5 pre-cut. Well, after we cut it out of the roadwork sign, this is what our drivetrain was built out of. It's legitimately this with Tetrix parts bolted to it, with those on the left being the walls and this piece on the right being the floorboard. So we were really able to have a unique design, because it's different. We used, this sign didn't cost anything, but at the same time, it's strong aluminum. It's 1/4 inch thick, I believe. That we were able to, we had the tools and we had the resources to cut out. We're a lot more of a wood shop and metal shop type team in that regard. But it makes for a unique design. It makes for something different. And that's what you want, is you want your robot to stand out. So this is, of course, what the robot looked like after we got some of the Tetrix channels bolted on. We got the Mecanum drivetrain, actually bolted on. And you can kind of start to see how it's coming up. So it's this combination of parts that are standard for first, Tetrix, Rev, Actobotics, Go Builda, and these parts that make it unique. And that's what we're looking for, is the ability to ask ourselves, hey, what do we have? What can we do? And build off of that every year. So, our first year, had someone told me this is what we'd be doing, I wouldn't believe them, because I didn't think our knowledge was there. But every year that knowledge base grows, and with it, your potential continues to grow. So this is, after we got the chain drives, bolted on. We actually got the motors up and running, or we got the motors bolted on, I should say, because we don't have a brand box on the robot as of this point. But we actually had one of our adult resources works on track vehicles for the military. So he actually taught us the ins and outs of that chain and belt tensioning, and that's a resource that it feels unconventional, but it works, and it's sharing that knowledge, right? Um, of course, like I said, wood, it works. Um, our scissor lift, the main crossbars were recycled aluminum and wood, just 2x4s, I believe, that we cut down. So that made for an interesting robot. You see a scissor lift that's up a couple feet in the air, and you see that it's being held up by wood, and that's interesting in a field that's dominated by specific building kits, right? Because it's unique. Um, you also a lot about this year's design for us was playing to what we can do and what we know we can do and what we know we can do well. So for us, it's not the same as other teams. For you, it's not the same as other teams. Um, we have a lot of parts now just on hand to be able to pull from to make interesting things like this. Um, but we have that knowledge to pull from as well. Um, oh my goodness, so much of this robot is knowledge that we learned in past years. So, for instance, for any of you that were there at the Florida State competition, there were 3 scissor lift robots in the semifinals. There was us, and then there were 2 other robots, Team Nova, and I'm forgetting the other team, Robotics, I believe, Robotics. But the other 2 robots were using screw drive scissor lifts, whereas this is winch drive. It's a pulley, and screw drive seems more stable, but when you realize from our point of view, we've been using pulleys the last 3 years. So we already understand enough about how a pulley system works to translate it to a scissor lift and make something that even stands out among other scissor lift robots. Just because that's knowledge that we had to build on, and it's knowledge that we can share. So, the question becomes, what can you do? What can your team do? Where can you pull these resources from? Um, you know, Even just around local areas. For instance, if you see this blue piece to the left of this image, that's a binder clip. That's just, it's obviously not difficult to find a binder clip in a school, but that's how we did a lot of our wire management throughout the season. Um, and it leads to really interesting problem solving ideas where, even though it's not what every other team is doing, we're accomplishing the same task through a much different way because we're thinking about it differently. So, don't let yourself get wrapped up in the first standard design. This is what every team is doing, so this is what must be successful. This is what we have to do. Let yourself really explore every outlet of the first tech challenge and really just consider, what are my strengths? What can I do? And what can my team do? What are, where the adults that help our team or that are, even just in your life, um, where can you get those resources? Because you have more than you think you do. Every single team in your league, and even just every single FTC team out there, has something to teach and something to learn. Um, they have something to give to you, and you have something to give to them in return. Um, Even these teams that have been doing this for upwards of 20 years, it's you have the ability. They have the ability to learn from you, and you can learn from them as well. So a lot of resources that, like I said, you don't know you have. For instance, we have Renaissance Jacks downtown, right? That's a legitimately active machine shop for robotics. Uh, and they've got all these different tools, and Mark has clearly stated, he's happy to have people come in and work on their robot in his shop, use their CNC routers and 3D printers to fabricate parts, and that grows your resources, grows your knowledge base to build off of. So, I want you to ask yourself, what works for you? Because it may not be the first standard design. It may not be, you may not have the means, you may not have the capability to build something insane. You may not, but you can work in the avenue that you have and grow that. So we our first 4 years we used a tank drive chassis because we knew it worked and we knew our drivers knew how to control it. And we used those years to build up our attachments so that we could work with some really crazy stuff without getting overwhelmed. So, that was a choice that we made. We made the choice that we knew tank drive was good enough for us to work. Um, so what works for you? That's kind of the point. Is there are a lot of materials out there, and there's a lot of knowledge out there that your team has access to, even if you don't know it. Go up and maybe there's a team in your league that is doing something really interesting or doing something that you want to be able to do as well. Ask them. I mean, you're just, if nothing else, look at their designs, see how they're doing what they're doing, because you're growing your knowledge base, you're growing your ability to build forward. It's even just to relate this to a real world example, right? You've only got so many materials out there to solve whatever problem you're trying to solve. So that means you have to be outside of the box when you think it. But even if your out of the box thinking isn't necessarily the easiest way to your solution, it gets you there in a way that grows your knowledge and really helps what's around you, because you only have access to what you have access to, but you have access to more than you think you do. Don't let yourself get stuck in a box of, I have to use these parts and nothing more. Really, it's that ideology that helps you grow as a team. Maybe your aces with the first standard design, maybe it comes naturally to you. That's great, but it doesn't come naturally to every team, and that's not, they don't need to change to fit what designs work best for other teams, right? So that's how you get some really interesting designs with out of the box thinking. I'm going to reference the team that we were able to mentor this past season, the Programming Pandas. So when we were able to meet with them, we had conversations about how to play to their strengths, because their strengths are very different from the strengths of another team. Coming from FLL, they decided they were going to build a small robot for this season. They had the smallest robot on the field in Northeast Florida. And that led to a lot of people noticing them as a different robot. It wasn't a carbon copy design. It was unique. And that created, that left the Programming Pandas in other people's minds. It got their name out there, because it was different. And that's the thing. Every team is inherently different. How is your team different, and how can you really use that to grow it? So, over the last 5 years, my team has been growing our difference. We've been changing and growing our knowledge base so that we can create something like this. Something that's out there, something that's different, something that doesn't look normal. Because nothing about robots are normal, right? And that's the fun part. That's the fun part. Make sure that you can really take what you're doing and make it unique, make it abnormal, because that's not only is that where you get a lot of fun out of the program, but that's actually where you do the most learning, by working multiple ways around a solution and choosing what sounds interesting. You know, we decided we wanted to build a scissor lift. That's a little weird to do in an 18 by 18 inch box, but we looked around at the materials we had. We saw our spare aluminum, and we saw, that we had access to the wood. And that led to this really interesting wood and aluminum crossbreed scissor lift. And that's what you want to be able to do as a team, is you want to be able to say, this is what I have access to, and with that, this is how I can succeed. Um, that's about all I got. Find what works for you and run with it.
Thank you so much, JR. We really appreciate you. And we'd like to ask you a few questions if that's okay.
Of course.
What a great presentation. So the first question that we have is from Hunter from team 16271 Flying Tigers. He'd like to know, since you have been in alliance captains before, what are some things you look at when picking alliance partners?
So when picking alliance partners, I look for not only consistency, which of course that's a big thing, is a robot that can do what it does normally, consistently, and well. That's a main thing, but not only that, I look for teams that work well with us. That's really how you stand out, in my eyes, is uh, you may not have the most capable robot out there, but if our teams work well together, if we synergize, then you're going to be towards the top of my list of I want to pick this team. So it's not just about robots, because you can have two very high performing robots that just get in each other's way. And that's not what you want. So you have to look at composition of what is our game strategy and what robot best suits that game strategy to score the most points. Um, of course, in relation to this last year, right? The main teams that I was looking at, of course, being Swamp Bots and Crazy Cat Ladies, were both using Mecanum drivetrains that were fast, and they had compliant wheel intakes that were able to collect blocks quickly and move them under the bridge, very fast. So because that's what works well for our robot. But maybe your robot doesn't stack as well. So you want another robot that can also stack so you can just get as many blocks on the board as possible. You really want to consider what works the best for you, right? I guarantee to you, had I not thought about teams that we work well with and teams that really we synergize with and that our robots are compatible, we wouldn't have broken 100 points. And that's kind of that's the fruit of that. That's what shows you, you want to see teams that work well with you and that their robot works well with you, because that's how you succeed.
Jim would like to know, what advice do you have for rookie teams?
So I'm really glad you asked. So for rookie teams, the best advice I have is get out there, get into your community, but also get out there in the league. Learn as much as you possibly can, because that's how you make a unique robot, but that's how you make a robot that works and stands out. I'm actually the StormTroopers are launching a full-blown mentorship program going into our 6th season. So, real quick, email robotics@sanjoseprep.org if you want more information. But we're looking for teams that are willing to mentor and be mentored. We want to create this knowledge base around Northeast Florida that can, help us skyrocket. We want to partner with Slick to make sure that teams are getting new information. To rookie teams, learn as much as you can from all teams around you. You can learn a lot from other rookie teams, and you can learn a lot from teams that have been doing this for several years. But also, get out there in the league and get out in there in the community. Usually by doing actually more community outreach, you're able to grow that knowledge base even more. You're able to see what you really can do. So definitely don't be afraid to step out and learn something new.
Okay, another question. That was great advice, by the way. Another question that we have is, how long do you test your prototypes before you know that they're ready to build?
So, funny story. Usually, as soon as we get a prototype built, we're mounting it onto the drivetrain to put it through its paces. Our mentality is drive it, break it, fix it. So we know if we put the practice hours on the robot, and it breaks, we're doing something right, because we're finding a point of weakness and we're fixing it. So, we'll build a prototype, we'll make sure that the servos and motors are working, and then immediately it gets bolted onto the robot to go through a lot of different testing, just to see if it works for our drivers, see if it works for our team. And that's what helps us. We had minimal hardware failures at every competition we were at because we were able to put in the time stressing the design that we had. And after like I said, as soon as it's built, as soon as we know that it's functional, it immediately goes on the robot so that we can test just how well it does its job. Because it may not do that well. And so then we're immediately on a different prototype, immediately on something else, or immediately on fixing what we're working with. So that's what lets us explore, because we're able to see what works and what doesn't in a real environment of, it's been moving blocks for 3 hours and the servo is getting weak, right? So we know maybe we need to use a different servo. So we prototype, we build, and then immediately it's testing, and it's never out of a phase of testing. If we're at a competition and something breaks, we know it doesn't need a quick fix, it needs a long-term fix. And how are we going to be able to do that? So even at state level competitions, we are still testing to see what works and what doesn't, because if you say that your robot's done, it's fine, you've cut off that learning opportunity.
All right, this is the last question we have time for. So how do you guys manage your time and stay organized?
So we meet 2 times a week for 2 hours. And we make sure that we're kind of breaking off as we work. So we've got our engineering notebook team that is by the robot, and they're checking in to make sure that everyone is to see what they're doing, so we can actually take notes on every single build day. But it's legitimately, as soon as that challenge video is done, we focus on designing. Usually we go through a week of design processes. We let ourselves really think over what we can do, prototype it in our heads before we prototype it in parts, because parts are stringent. We only have so many parts that we can use. So definitely that's the thing. We usually spend a week on design. We get the robot built in about a month, and that's including some tweaking as well. So this last year, we decided we were going to focus on 2 different robots. We built the mouse droid, that just standard H chassis tank drive, and it just had a servo gate. Its whole job was to move blocks, because that way we knew that we had a working robot that took us 2 weeks to build, because we were using it to teach other people how to work on robots. So we spent 2 weeks on that because we knew we could spend extra time to really make sure that our ST5 robot worked. So definitely, of course, meet several times a week is the best advice I've got. And because, even when you're not meeting, you've got people that are thinking about it. So meet several times a week and keep communication open, because you can have that insight. You can have kind of an aha moment that this may work, right? So that allows you to constantly, you may have a member that's constantly thinking about what's going on, constantly thinking about different designs. And that communication helps you manage your time, because it gives you other things to focus on, so that once you've set a deadline, that you can push through that deadline and then immediately go to work on maybe a different prototype, maybe something that will work better but would take longer to make. So choose what works for you, and then build off of that into, after you get what works for you built, maybe try something that doesn't. Maybe you've got a linear slide lift built, but you want to try building a scissor lift. Build the slide lift first, and then go into prototyping a scissor lift, so that it's not necessary, but it can help you. If that makes any sense whatsoever, because that was kind of a ramble.
So this will conclude our presentation for today. We are so excited to compete with you guys next year. Thank you for taking the time to share your awesomeness with us, Stormtroopers.
We can't wait to see what. Oh,
Oh, sorry.
Yeah, totally.
My bad.
No, go ahead. We can't wait to see what you guys will come up with next season. Next Saturday at May 16th at noon, we will resume our series with a presentation from the Boombots. You won't want to miss it. Thank you for joining us, and we'll see you next time.